Okay, this video is going to describe a type of reaction called a radical halogenation reaction. Today we're going to focus on these radical halogenation reactions on alkanes, but later in the semester we can see that they'll happen on other molecules also. This is a really useful reaction because it generates alkyl halides. In the general category of the reaction is a substitution reaction. So let me write out an example of this reaction, and we'll look at the mechanism behind this reaction, which is really pretty complicated. It's complicated for a couple reasons that we'll see. One is that there's multiple steps involved in this simple substitution reaction, and the second is that it's a radical-based reaction, which means we're going to be moving one electron at a time often instead of the two electrons that we're used to seeing in most of our mechanisms. So here's an example of this type of substitution reaction. We're going to have maybe methane, react it with our halogen, chlorine, in the presence of high energy light, indicated by this H nu sign. This is a big clue that you've got a radical-based reaction. This high energy light splits a bond to generate radicals. And so whenever you see this high energy light, you should think about radical-based reactions. And this reaction will result in our alkyl halide and hydrochloric acid. So hopefully you can see why this is a substitution reaction. A hydrogen and a chlorine have switched places. One has substituted for the other one to generate these two products. Okay, now there are multiple steps involved in the formation of this substitution reaction. And those steps can be categorized as either initiation reactions, propagation reactions, or termination reactions. Now what I'm going to do is outline the general characteristics of each of these reactions, give you an example that's pertinent to the reaction that we've written up here, and we'll see how the combination of these different steps can lead to an overall substitution reaction. What you also will notice is that it's potentially a messy reaction with lots of different steps, and that's the reality. This is a messy reaction. You tend to get a mixture of products. However, it's a really useful reaction because it's one of the only ones that we have in our toolkit to sort of make these non-functional alkanes into molecules with functional groups that can go on and synthesize other molecules that we're interested in. So it's a very important reaction. Okay, the first type of reaction we're going to talk about, one of the steps in this overall substitution, is an initiation reaction. It's generally characterized by a reaction that has no radicals in the reactants, and it forms radicals as products. Here, the halogen is the most important one in this particular reaction. We've got a chlorine-chlorine, and in the presence of UV light or high energy light, this molecule, the bond between the chlorines, can split. If you look at the arrows I've drawn here, I've drawn fish hooks, single-headed arrows, and that indicates the movement of one electron. So what we're saying is this high energy light is absorbed by the chlorine-chlorine bond, and it lyses, it breaks in a homolytic fashion. One electron goes to one atom of the chlorine, the other electron goes to the other, and we form radicals, right? Two chlorine radicals. Radicals being unpaired electrons, very reactive. Unpaired electrons are unhappy, very reactive, and they like to steal electrons from other things. Okay. If we look at this overall reaction, we can see why it's an initiation. We have our chlorine with its paired electrons in a bond, or lone pairs around the chlorine, no radicals, and then two chloride radicals as products. Now, one of these chloride radicals can go forward in a propagation reaction. Again, that is an unhappy unpaired electron, and it can steal an electron from another bond. It could steal an electron from one of the carbon-hydrogen bonds in our methane. We can indicate that again by a set of fish hooks to form a new hydrogen chlorine bond, our hydrochloric acid, and leaving behind a new radical, our methyl radical here. Okay. Again, this is a propagation reaction. We had a chloride radical as a reactant. We ended up with a different radical as a product. That's the hallmark of a propagation. Okay, termination reactions are where two radicals come together, and this seems like the best case scenario. If you have a molecule with an unpaired electron and another one with an unpaired electron, just have them pair up in a bond. And that is a reaction that can occur. We have another chloride radical. Remember, we had two that were generated by our initiation reaction. It can join together with our methyl radical. To form our alkyl halide product with a new carbon chlorine bond associated with it. Okay. Radicals as products terminating with each other to form a non-radical product. Now, if we sort of think of these different reactions as different steps in an overall substitution reaction, we can see how they can combine together to form this overall net reaction. So if we start canceling out molecules that are created and then used up, we end up with this net reaction. So let's look. Here's chlorine. Cl2 is a reactant. Do we ever form it as product? No. So it should stay as a reactant. We see it here as a reactant. Here are two chloride products. Well, we use those two chloride products, and so they cancel out with each other. And as we can see in our net reaction, we never see the presence of radicals as reactants or products. They're present in the different steps that lead to the overall net reaction, but they cancel each other out. Here's our methane. We use methane. We never form methane, so it should stay as a reactant. We see it here. Hydrochloric acid is a product. This methyl radical is formed, but then it is used up in the termination reaction, cancels out. And our final alkyl halide product is a product. It's not used up as a reactant somewhere else. So you can see how these different steps represent this overall net reaction that we see. Formation of radicals in an initiation reaction, the use of those radicals in either a propagation or termination reaction, taking an alkane with a halide, forming an alkyl halide, plus our, in this case, hydrochloric acid.